Hello there, dear follower, and welcome back. So now that we know the geometry, the domain, everything is clear, let's move now to OpenFOAM and let's get our hands dirty. So here you have your case directory. Let's focus in Cessna 210 playground. Okay, so this is the first case. So this one I would like to use it to demystify snappyHexMesh. So you will see that it's not that intimidating. It's quite easy. Okay, just use the default options and you need to read only the right files. Okay, so let's focus here. As user, you have automatic scripts. So what I would like to do first here is let me go and open an snappyHexMesh here and revisit this step. So remember that basically snappyHexMesh do have 3 steps: castellation, snapping, and add layers. That's all. That you have it here reflected now in the body of this dictionary, and then you read the geometry. Okay. So the first thing is remember read the geometries. So here we're reading geometries. I already put here all the geometry. So in this case, in constant, I put the right geometry. So we have some new geometries, ref zone 1 and 2 and so on. So these are refinement zones. So I put a lot of stuff here. So just read your geometries here. I create an internal entity. So this one, it is equivalent, if I will recall, to ref zone 1. So it's up to you. Then you go to castellation. In castellation is where you do all the refinement, okay? After castellation, you do the snapping, the body fitting. Here, you don't do any refinement. The final mesh might change the cell count, but it would change because you are doing X swapping and so on, and flipping edges and doing some small surface subdivision, but it shouldn't change by that much. Okay, all the edge refinement, surface refinement, volume refinement is done here. And then at the end, you add the boundary layer. Okay, you add boundary layer again. You don't add any more cells besides the cells not related to that inflation layer. But let's focus in castellation. Castellation, the first step is image. These are the edges. So remember, you resolve edges, then you resolve surface, and then you resolve volume regions. Let's talk about this image file. Okay, so we know that there is a surface feature dictionary that you can capture that. So let me go here. You capture that. Okay, so we know how things work, but I would like to show you something how you can do it, or to revisit how you can do it visually, but also I want to show you how can you intersect geometries, okay, using commands from OpenFOAM, and also how can you do it using paraview, which is very interesting. I love that feature. Okay, so I think you will enjoy this. So the first thing is, let me open paraview. So I will use paraview standalone. You can use your compiled version with OpenFOAM. It's up to you. Look at that, and using version 6 is relatively new for the time of this recording. I recommend it. They introduced very nice improvement. So let me go here and launch it. I have my version there, and I will open one geometry. And let me open actually the geometry inside. Okay, let me do things the right way. Let me enter into the Cessna playground. Okay. Paraview 6. Okay, and I will open a geometry. So constant geometry. And let me open let me open body. Okay, so we have our body there. Fantastic, nothing to comment to comment about that. Remember, I already intersected everything, so this is perfect. Okay, and remember here you go to filters, alphabetical, feature edge, and this will be equivalent to surface features. Remember that the angle is the complement of the one that you are going to use in surface features. Okay, and there you go. You extracted the edges, put it there. And these are, using this angle, these are the edges that you are going to extract, and there then you can enforce the fit in there. But look at, by using this angle, you are not capturing everything, so you are missing this small area. So remember that you just change here this angle, apply, and there you go. Now you can resolve better, but pretty much it is capturing everything. Then you have some extra regions here that maybe you can erase or eliminate those regions. We're going to see how to do that later. The selection, basically you need to select what you want to do to use. So I would like to select, look at this one here, this ring, because there I'm going to attach the propeller, and maybe I would like to have a very different refinement in this ring here. So you can have the whole aircraft refinement level 4, and then in this ring here refinement level 6, as I have actually here. So as you look at here, I didn't put it. So yeah, we can add the ring there and add different refinement, probably in the other cases. So how we can select edges here? So that's relative easy. So let me hide there the geometry, put it here, that we view, and here you have the selection. You have to subtract and add, and then you can choose selection interactive, or you can select cells with a polygon. Let me do it like this. Wow, I hope. And there you go. You select it there. So now you can extract that selection, and let me show you something that can be okay, or later I will show you that. So if you want to extract that, you have it here. Extract selection. You extract it, you have it there. You didn't see it because the default color that I have is white. So I need to change my default settings. And there you go. Probably I missed something there, so it wasn't a very nice selection. So let me go there. Yeah, so I can look at that. The plus is enabled there, so I can just reselect and add to that data set there. And let me go here. So let me select again here is this one. And there you go. So as you see, you can do, it's very flexible, you can do a lot. It's not very easy to use. Okay, sometimes you have funky lines and it can be tricky to do that selection, but yeah, you can get your way around here. And boom, there you go. Put it here. And there you go. So now it is a nice selection. And now what that I can do, I can export this and use it in OpenFOAM, no, the image file. So as you go here, save data, you can save that as STL or OBJ, but look at that, you don't have those options enabled there. Why? Because you need to convert this, you need to extract the surface. So if you go to filters, let me surface, extract surface. Okay, so it will create a polygonal selection or whatever is here. You have extract to the boundary surface, put it there, and after you extract that, you will be able to save that as a BTK file or OBJ. And to mention, I recommend you to save OBJ because 2 reasons. Okay, so look at that, when you use surface features, you are saving an OBJ. But the BTK format, that is also very flexible, but there is a problem with the latest version of paraview and OpenFOAM, and they are not the same BTK library, so I don't recommend to do that. But now let me go here, save data, and look at that, save data. You have all the options, so you have the STL option, okay, and then also the OBJ. The STL is not going to work, it has to be OBJ. The BTK option should work because there is another tool to do conversion from BTK to image. But as I mentioned, there is a problem that now paraview use a newer version of the BTK library. In OpenFOAM you have an old version, and then you are going to get an error. Okay, it's just compatibility of version. It's not a big of a deal, but go always for the OBJ format. You go there, I will call it ring, okay, and that's it. I should have my ring. I don't know where I saved that. Okay, I save it here, and there you have the ring file. Okay, or I think I overwrite. Okay, let me go ring 2. Okay, I have ring 2. Okay, and that's it. That file, you have it there, and it's perfect, it's valid, and then you can select it. You can add it in your dictionary here. You can put ring image and it will work, okay? But then let me show you, for instance, another trick now. For instance, let's say that you don't like these lines there, you want to remove that from your dataset, okay? So here to deselect what you selected. So to do that, it's pretty much the same now that we have done. Go here, then let me do this polygonal selection there. And there you go. So it selected something in the back, also something there. Okay, so let me go like this. So that one will erase that selection. And there you go. So as you see, it's you have all the options now to do the selection. It's not as easy now as you recall. Mesh Mixer is super easy. Here, yeah, it's a little bit tricky. There are many steps involved, but you can get your way around, okay? But the issue is that, okay, I want to remove this from the dataset. If I extract that one, you're going to extract that one. So is it possible to do an inversion? Yes, it is possible. You don't have it here. And just to show you, go here, edit or view, where find data. It should be here, find data. Here you have all your selections. Now look at here, you have this invert selection, extract, apply, remember the color. I didn't change the color. There you go. And voila, you remove that nasty edges, and then you can do the same with these lines here and here, okay? Or whatever you don't like it, you can do it. So this case, that is not that painful. Sometimes you can have very difficult geometry, so doing that manual selection is, yeah, it's a little bit painful, but definitely something doable. Remember that also you can define that image file manually, so you can get here and get the vertices from the STL. You can get those references now actually from let's say here in this case onshape, so you have the coordinate of the vertex and the next one, so you put it there and then you get the line connecting those 2 points, and that's it. Okay, so that is how you do this stuff in paraview for the edges. So let me close here. We know that you use surface features, it will work. Actually, I don't know what I closed. Now let me show you the other part just to end here that is very interesting, because now let me go, and in this case let me go back here and on split geometry. Now it's this one by parts, and let me take fuselage and rudder. Okay, so we have 2 geometries. And the issue here is that remember, remember that this one is penetrating. So you can do your mesh in a Snappy with no problem, but you are not going to capture these edges. You need to capture that. So how can you do this without entering into fancy CAD tools? There is a way to do it using some nice tools that you have with OpenFOAM. So let me show you that tool, and it can be also done with paraview. That will be probably the CFD cookie, or later I can show you that. So as you go here, you will see OF12, and you have something that's called surface. So there are many surface manipulations tools. Okay, the names are self-explanatory, I would say, but there is a nice here that is surfaceBooleanFeatures. It will do what? A Boolean between surfaces. So those 2 surfaces that visualize in paraview, we can do the Boolean. It's not going to create a new STL. It's going only to find that OBJ file, and then you can use to enforce the image. So it's very useful. I love it. I like it. It's something that you can do also using Python libraries or whatever, but you have it here in your Python, in your OpenFOAM environment. So this one works. Let me see. It will take surface file. Okay, the surface files that you are intersecting, and then the action. So Boolean, intersection, or what is the other? Or subtraction, I think. But in any case, you misspell something, you get it. So let's use it. So I go to geometry by parts, and let me use fuselage. geometry by power, and let me use, what is the other rather, and I don't recall the options. Control D. Okay. It will ask for the data structure of the OpenFOAM case. So let me put it there. Okay, so it will ask for that structure. I have it here. I put it in the wrong directory. Okay, don't do what I'm doing, please. Okay, let me put it there, and there you go. So yeah, you have union, different, and intersection. So I want to find the intersection, okay, between those two intersections. And there you go. So it will put the intersection in this folder, constancy, that you have it there. And now that I have it here, you will have the intersection, the OBJ. Okay, so you will have, your intersection will be fuselage rotor intersection. So let's look at that in paraview. Okay. Extended here, and it will be HexMesh, this one, fuselage rotor intersection, HexMesh. Open there, change the color, and there you go, the intersection between those two. And fantastic. Okay, it works really, really well. And just to show you, to confirm, so let me reopen the geometry. You have the body there. Okay, and look at that, you have that nice intersection. So now you can have those self-intersecting body or non-manifold bodies, whatever you want to call it. But now you have this image file, and now you can force the mesh to snap to this edge. So you can capture that very nicely. So what I was saying, that OpenFOAM, snappyHexMesh is super flexible. Doing these small steps, this stuff that we're doing, maybe you might think, oh God, but this is tricky. Believe me, if you go and use, for instance, fluid meshing or StarCCN or ANSA for dirty geometries, things are very tricky as well, probably trickier than here. So it's extremely flexible. I really like that. Very fast, when you demystify snappyHexMesh dictionary, you can do all these operations extremely fast. Okay, everything can be parameterized, can be automatized very, very, very easily. So that's all. Okay, so let me close there, let me go there and close this one. Please don't do what I did there, moving files. Now keep things very clean. Let me do also phone clean tutorials. Okay, and that's it. So at this point we cover features. We know how to capture the features, put the edge refinement that you will like, and that's all. So remember, we're demystifying this dictionary. Use it as a template. Read your geometries. It's up to you. These parameters we already talked. Leave it as they are. Okay. For me, I never change it. I only change this one when I need much larger meshes, or probably this one. But here, nothing to change. Okay. We're reading here the image. So here you use a refinement level. Remember that everything is done in reference with the background mesh. Okay. So 0 will force only the snapping, but as you put 2 there, it will now add 2 refinement levels at that edge in reference to the size that you have in the next cell next to the geometry. So now from features, let's move now to refinement surfaces. Okay, so we will address this in the next video. Okay, so see you next time. Bye.